Assalamualaikum and hello to Dr. Nordin. My name is Nur Maisarah Bt Ramlee. My matrix number is 196309 and today I'll be presenting my dimensional analysis presentation. Firstly, the definition of liquid. So liquid is a sample of matter that conforms to the shape of a container in which it is held and which acquires a defined surface in the presence of gravity. So some of the characteristics of liquid is it has definite volume, but indefinite shape in which it can take the shape of the container it is in. And then liquids are fluid. It is able to flow and take any shape. So fluid, there's a lot of fluid like liquids and gases. So liquids like gases undergo diffusion when mixed, and it is usually considered incompressible. Unlike gases, liquid has a distinct surface in which it doesn't need to take the container shape, but it also can take the container shape. Okay. So what is dimensional analysis? Dimensional analysis is a mathematical technique used to predict physical parameters that influence the flow in fluid mechanics. So, heat transfer in thermodynamics and so forth. It involves the units of dimensions, for example like MLT, which is mass, length, and time. So it is commonly used to determine the relationship between several variables. So two of the methods of dimensional analysis is Rayleigh methods and Buckingham's pi theorem. So next we will be going into the example of Rayleigh methods. So this is the example question. The velocity of propagation of a pressure wave through a liquid can be expected to depend on the elasticity of the liquid, represented by the bulk modulus K and its mass density rho. So established by dimensional analysis, the form of the possible relationship. So first thing is we need to determine the dependent variable and independent variable. So for this question, the dependent is u, which is for velocity, and the independent variable is rho and k, the mass density and the bulk modulus. So next step is we need to write it in the form of a functional relationship in which it is written as dependent variable equals to a constant and then independent variable to the power of a and independent variable times the independent variable 2 to the power of b and so on. So for this question, the dependent is u, dependent variable is u, so c is the constant. And then we have our first independent variables, which is the rho to the power of a, and then second independent variable k to the power of b. So next down is just list down the dimension for each of the variable. So for u is lt -1, rho is ml -3. And for k is ml -1t -2. So next thing is we need to solve for the power a and the power b. So the way to do it is to just compare for each of the dimension, compare the power of each of the dimensions. So for the first, for example here is there's m to the power of 0 is equals to m to the power of a times m to the power of b. So we write it in the term of powers, 0 equals to a plus b. So we do that for all of the dimension m, l, and t, and then we solve it. We will get a to the power of half and b to the power of -half. So the possible equation is, so we write down the a back into the original equation, which is this, the functional relationship. And then we will get u equals to c sec k over rho. So that's how we solve the dimensional analysis using Rayleigh's method. So next we're going into Buckingham pi theorem. So this is an example of the question. Consider a liquid in a cylindrical container in which both the container and the liquid are rotating as a rigid body. the elevation difference h between the center of the liquid surface and the rim of the liquid surface is a function of angular velocity, fluid density, gravitational acceleration, and radius. Use the method of repeating variables. Repeating variables is Buckingham's pi theorem to find a dimensionless relationship between the parameters. So this is the diagram. So for step 1, we need to determine the parameters. So in this question there are 5 parameters, which is h, the elevation, the omega, the angular velocity, the rho for density, fluid density, G is for gravitational acceleration, and R for radius. So there are a total of 5 parameters. So step 2, list down all the dimension of each parameters that we have. So next we're going into step 3. So step 3, we are gonna determine the number of non-dimensional group or the number of pi's. So the formula is n minus m. So here is the formula n minus m. So for n minus m, n is the number of variables that we have earlier, which is 5. So parameters of variables. So we have 5, so that's our n, 5, and then we're going to minus by n. N is the number of dimension that we have in this problem. So the dimension that we list out earlier, we have m, l, and t. So that's 3 dimensions. So n minus m, 5 minus 3, and we'll get 2 number of pi's. So next is we need to choose 3 repeating parameters. So the 3 repeating parameters, using the guidelines. So for the guidelines is that each repeating parameters must be dimensionally independent. So we need to choose independent variables only. So we choose the repeating parameters, angular velocity, density, and the radius. So next, for step 5, we will generate the dependent pi. So for the first pi is the dependent variable are going to be our constant. It is almost the same as Rayleigh method, but instead of the constant, we use the dependent variable as our constant. So our first dependent variable is h. So here we have h, and then we're gonna write down the functional relationship, the same as the Rayleigh methods, in which the repeating parameters to the power of a, and then second repeating parameter to the power of b, and third repeating parameter to the power of c. So list down the dimension, and then we're going to compare the power of each of the, compare it to n to the power of 0, t to the power of 0, and l to the power of 0. So we're going to get b to the power of 0, a to the power of 0, and c to the power of -1. So substitute back to the original functional relationship, and we'll get pi1 is equals to h over r. So next, we're going to solve for pi, the second pi. So change the constant to the second dependent variables, which is the gravitational acceleration, and the rest is the same. So list down the dimension and compare to m to the power of 0, t to the power of 0, and l to the power of 0. So we're gonna get b is equals to 0, a is equals to -2, c is equal to -1. Okay. So we substitute back the a, b, c into the functional relationship, and then we'll get pi2 is g over omega to the power of 2 times r. So next, The final step is that we write down the relationship between the pi's. So what we do is the first pi, we write the first pi equals to the function in bracket to the second pi. So for example, if you have 3 pi's or 4 pi's, so the first pi is equals to the function of the rest of the pi's in brackets. So that's how you write the final functional relationship. Is the first pi equals to function of the rest of the pi's in brackets. So that's the end of this dimensional analysis presentation. So thank you very much.